Hi. Next session is taken by Mr. Sethuraman O, research scientist from Kerala Blockchain Economy, who gonna take a session on basis of chain code Hyperledger Fabric, who completed MCA from Indian Institute of Information Technology and Management Kerala on machine intelligence. He has contributed course contents for the certified Hyperledger Fabric development course. It's my pleasure to welcome you, sir, to the platform. Sir, please.
Yeah, thank you for that warm welcome. So I hope the audio is clear.
Yes.
Yeah. So let me just share my screen first. Yeah. So yeah, the screen is visible, right? Hello. Yeah.
Yes.
You guys can see the screen, right?
Yes.
Yeah. Welcome. And yeah, like he mentioned, my name is Sethuraman, and I'm working as a research engineer here at Kerala Blockchain Academy. And I'll be, we'll be exploring the concepts of chain code today. So, if I understand correctly, for the past couple of days, you people have been exploring blockchains, right? There have been a couple of sessions in the past couple of days. So I hope that you have a understanding of what blockchain is, right? Yeah. Here's a question for you people. So, what according to you is the most, appealing feature of this technology? When it comes to blockchain, what according to you is the most appealing feature of blockchain? Now, this is a subjective question. There is no right or wrong answers. Just I want to know your thoughts. So what do you think is the most appealing feature, or why would you prefer blockchain for an application? Hello. So anybody can respond, like why do you think, or what according to you is the most appealing feature of this technology? I'm sorry, I think the audio is breaking up a bit. Yes, you are saying? Hello?
Sir, they are responding in the chat window.
Oh, okay. Yeah. Decentralization, no need of a central. Okay. Okay. What do you think of this? What do you mean by this decentralization or no need of a centralized authority? How can it help an application? Or in the case of, let's say, if you take the example of the Bitcoin network, how do you think this process of decentralization or no central authority, how it plays out in that network? How do you think it plays out in that particular network? In the case of Bitcoin or Ethereum or any such network, how do you think that this concept of no central authority or decentralization plays out? Yes. Yeah. Okay. Direct communication, better and safe way. Oh, okay. Here's a question. You said that it's direct peer-to-peer communication between the producer and the consumer, or the sender or the buyer or whatever, right? So who conducts these transactions? Like, for example, if I take the example of a bank, if I am transacting, if I am having a transaction with my friend through a bank, I can say that the bank is the one who is handling the transactions, right? So when you look at Bitcoin, the Bitcoin network, who do you think conducts these transactions? Or how does no, I mean, who is responsible for it? Like, in the case of our normal day-to-day transactions, you have the banks, right? You have this huge system that is in place that takes care of the transactions. So or that takes care of the logic behind these transactions, like how it should happen, or all these things like that. So in the case of Bitcoin, where do you think, or who controls the flow of that transaction? Yeah, I'm getting some answers. Nodes, peers, and all that. Okay, so what about Ethereum? I was hoping, I think that you guys had a session on Ethereum yesterday, right? So what about Ethereum network? Do you think that it's the nodes that control the flow of the transaction, or how does it work? I'm not asking who is initiating the transaction. I'm asking who controls the flow of the transaction, or who controls the logic of that transaction. You have no central authority, right? You have nobody in between. Miners, okay. Yeah, is it miners? Does anybody want to support his answer, or is there any new answers or things like that? Do you think it's the miners who addresses the flow of the transaction? Remember, I'm not talking about who initiates or who creates a block or anything, but where does, or how do you define the flow or the logic of that transaction? Just compare it with the bank. Like, you have the bank who, whenever you conduct a transaction in your normal, using your normal account, you have your bank who debits the money from one account and credits it to the next, and who controls all the logic that comes in between. So what about these networks? Who does that, or what does that? You have no central authority, right? So what does that? Any ideas, suggestions? You see, when we talked about the features of blockchain, for me personally, one of the most interesting aspects of this technology was the fact that it helps you remove the reliance on a third party. Okay, so when you're thinking about a normal transaction that you conduct with a bank is technically what you call a third party, right? So here you don't need, someone has already mentioned that part, you can have peer-to-peer communication. So according to me, personally, I feel that that is the most compelling, you know, reason as to why I should choose such a technology, because I can remove the reliance on third parties or middlemen or whatever you call such entities. So how does that happen? Do you have any ideas regarding how we remove the necessity of a third party or a middleman in the case of a blockchain network? How do you think that happens in networks like Ethereum or Bitcoin or things like that? Any ideas as to how that happens? You can just use the chat for your answers. There is, like I said, we are all learning here, so there is no right or wrong. You can just speak out your mind. Okay, peers verify it instead of a single many nodes verify and approve it. Yeah. So okay, so you have peers now. I am assuming that you're talking about the Bitcoin network. Uh, so what about Ethereum? What was so special about this Ethereum network? Yesterday, I think you had a whole session regarding Ethereum, right? So what is the difference between this Bitcoin network and Ethereum? You're saying that peers are the ones who verify the transaction. Like I said, I'm not talking about the verification part. I'm talking about the logic. Where does the logic of this transaction reside? Usually, you have these third parties who helps you with this transaction, right? Or helps you conduct these exchanges. Like you have brokers, or you have other middlemen who helps you conduct this transaction. Yes, I think Ethereum can be permissioned, and there is a smart contracts. Okay, now what is smart contracts? What do you mean by smart contracts? Now, before we get to the smart contract part, let's just break it down, and let's just talk about contracts in general. Okay, so what do you mean by a contract? What is a contract? What is a contract, or yeah? What do you mean by a contract? Logic, logic. No, I'm not agreement. Okay.
Commitment.
Okay, it's a commitment. So when you look at a contract, it is basically a set of rules, right? A set of rules that all the parties agree to, right? So when you draw up a contract, you are basically stating a set of rules that is agreed upon by two or more parties, right? Yeah. So that is what a contract is, right? Is there any other opinion or any other definition that you would like to provide of what a contract is? It's basically a set of rules that is agreed upon by, yeah, it can have a legal nature. Of course, it can have a legal nature. So it is technically a set of rules that is agreed upon by two or more parties. Okay. Now, where do we fit a contract, or where do we usually use a contract? So whenever we think of contracts, our mind always tends to run towards these high value transactions like that of a land, or big transactions that have huge amount invested in it, like car, land, or properties, or things like that, right? So whenever we conduct these transactions, you will draw up a contract. You have these stamp papers and everything, and you will draw up a contract. And you know uh, a contract is actually part of such big transactions. And when you look at these transactions, let's say for example you are buying a land from someone. Let's say you are selling your land, or you are buying land from someone. You have certain other players who are part of these transactions, right? You might have the officers, the government officials, or you might have the brokers, or people like that. So what is their role in that transaction? What do you think is the role of these people in that transaction? You have a transaction. Suppose you're buying a land, you have the buyer, and you have yourself, and then you have these separate entities, who are there, who are part of this transaction. So what role do they play? Okay, contract comes in where, okay, yeah. So I'm just asking, like, when you take a transaction, for example, selling or buying of land, apart from the, yeah. So the thing is, when you look at such a transaction, like, a high value transaction, these third parties, yeah, the endos, yeah, okay. So these third parties, like, the government officials or the brokers or people like that, what they do is they help validate the contract, right? They help verify that all the things are according, going accordingly, or all the rules are followed, or all the things, that are mentioned in the contract, they are fulfilled. So basically they help you validate this contract, and thereby validating the transactions. That is the basic role of these third parties that are, part of your transaction, especially when you're talking about a transaction like, a high value transaction like the buying or selling of land, right? So is that part clear? So you have these third parties who help you validate these transactions. So the thing is, this is, we were talking about, selling of land and buying, and such big assets. What about normal everyday transactions? Now here's a question that I would like you to answer. So yeah, this is the question. So suppose I go to my local grocery guy, or shop, and I want to buy a packet of cookies or biscuits. Do you think this transaction abides by a contract? Do you think we need a contract for this transaction? So yes or no?
Yes, we can have the contract for this transaction. So when the good is, transport, na, that time money can be, triggered.
Yeah, exactly. So in order to put it, in general statement, I would say that every action that is of a transactional nature, which means, every action that has an exchange of some commodities, will abide by a contract. Okay, so this is a general idea. Like, if a action that you conduct, it is of a transactional nature, it will have a contract, right? So the thing is that contract need not be written. Okay, it need not be hard coded, or it need not be written, a contract. When you are buying a packet of biscuits from your local shop, you don't need 100 rupees stamp paper or anything. You are just going there and you're buying it. You're not even aware of a contract. But the thing is, since this action is of a transactional nature, there is a contract, or there is a set of rules, that is governing that particular transaction. Can you try to guess what those rules might be. Like, you're buying a packet of biscuits. What can be the possible rules in buying a biscuit? When you conduct such a transaction. Yeah, fixed price. Yeah, you should, there should be a fixed price, and you should get the correct commodity according to your price, and the money should be proper, like, it's not counterfeit or anything. So the thing is, and if you have any balance, you should be repaid the correct amount, right? So there are these rules that we follow even in such a transaction, right? So the thing is, this is basically, since you have a set of rules, that means, and since you follow it, that means you are abiding by a contract, even for such a small transaction. Now, what do you think this shopkeeper, what is his role in that transaction? When you look at it from the perspective of a contract and asset, what do you think is the role of a, shopkeeper in this transaction? You see, just like we have the registrars or government officials in high stake transactions, here when you look at the role of a normal shopkeeper, you can see that he basically helps us validate those rules, right? He's the one who, yeah, the provide commodity, and he is the one who basically, when you are it's the responsibility of the shopkeeper as well as yourself to keep that contract, right? So he is the one who is there, who gives the correct commodity. He makes sure that the money is authentic. He gives you the balance, in case you have a balance. So when you look at it from the perspective of contract and asset, he is similar to that of a third party, right? He helps us carry out the transaction, and he provides us this commodity by carrying out the transaction, and he makes sure that all these rules are followed during that transaction. So even in a transaction of this scale, like, here we are basically talking about buying a packet of biscuits. So even in such a transaction, you see that we can separate you can actually categorize those elements as buyers, assets, sellers, and a third party, right? In our case, you have the shopkeeper who helps us conduct this transaction, and so he is basically acting as a third party, or who someone who verifies all this contract so that we can conduct the transaction. So that's the basic role of a shopkeeper. Okay, so the point here is that no matter the transaction, no matter the scale of the transaction, you will always have these people, who helps us conduct this transaction. That's how things work, right? You can take a transaction of any scale, and you will find someone who helps you, or who you rely on to conduct these transactions. Now the question is, what if I replace that vendor? Okay, you have this vendor, or this shopkeeper who's helping you with this transaction. So what if I replace the vendor with a vending machine? And so in that such a scenario, what will be the change that happens in that particular scenario or particular transaction? And do you think that if I replace a person with a machine, do you think that the contract still holds? Yeah. Yes, I mean, is it, and yes, it's somebody has just answered yes. Is it a general yes, or a particular to a particular part of the question? So would you care to elaborate? Or how will it change the transaction? How do you think that replacing the vendor with a vending machine? Yeah, automatic. Yeah, so yeah, you're getting there. Just build on that. Somebody just said automatic, so just build on that. What do you mean by automatic? See, when you're talking about, yeah, machine plays a vendor role, or he takes away the need of a vendor. That's the question, or that's the point. Like, when you're talking about a vending machine replacing a vendor, the thing is, this machine basically removes the role or the third party that is part of that transaction, right? You have a Yeah, rules are implemented in hardware. Yeah, so the basic concept is that when you are replacing a vendor with a vending machine, what you are doing is that you are removing the need for a third party in that transaction, and you are replacing it with a machine, and you can directly conduct these transactions without the need of a third party in this particular transaction, right? You know how a vending machine works, right? You just insert a coin and you just type what you need and you will get it, right? It might be a code or something, just type the number and of things and you will get it. So here, instead of a person or instead of a separate entity who is there to facilitate the transaction, I can directly conduct this transaction without the need of a third party. So the thing is, when you replace the vendor with a vending machine, you are simply removing the need of a third party. Is that concept clear? Do you have any doubts regarding this you know question? So here, yeah. So what about the contract? Yeah, somebody said that the contract is implemented in hardware, right? The thing is, so even when you are replacing the vendor with a vending machine, all the things that is carried out by the vendor, what we do is we take hardwares and a bit of code and we basically implement it in the hardware itself. So even if you are replacing it with a machine, the thing is this machine still holds that contract. you know uh, the thing is, it holds this contract using hardwares and softwares. So yeah, so this is what we are, yeah. When you replace this vendor with a sorry, when you are replacing this vendor with a vending machine, you can see that we are removing the reliance on a third party in order to conduct a transaction. And like someone mentioned, we basically mechanize the contract, the set of rules using hardware. And the thing is, when you think about smart contracts, someone mentioned smart contracts, right? So uh, this vending machine can actually be considered as a very primitive or very early ancestor of smart contracts. Now, why do you say so? Why do you call it smart? Okay, that's the question. Like, we hear that we have these normal contracts that we use in day-to-day transactions. So what makes it so smart? What makes a vending machine so smart? Okay, so the answer is that when you look at a vending machine, it doesn't need a separate entity, or it doesn't rely on anyone to enforce these rules, right? It's a piece of machine or it's a piece of hardware that can enforce the rules of a transaction on its own. Okay, so it might be a simple if else statement, but the thing is, this machine is capable of enforcing the rules of a transaction or enforcing the contract of that transaction on its own. And once validated, or once it enforces these rules, this machine can perform the necessary actions required or by the required by the transaction. Like, when you are trying to buy a packet of biscuits, once it makes sure that you have the proper amount and proper currency and everything, it then starts the transaction for you. It just gives you the biscuits. So yeah, I'm not talking about intelligent systems. I'm just talking about a normal, a vending machine. The smartness. I'm just talking about the part where we call it smart. The reason why we call it smart. Yeah, intelligent system and AI. It's a different field. It's yeah. I'm not diving to that part. Here I'm just talking about how we, or why we call it a smart, an ancestor of smart contract, or how do you define the term smart in the context of a vending machine. The thing is, with the vending machine, like I said, it is capable of enforcing the rules on its own, or the rules of a contract on its own. And once it enforces these rules, it is also capable of performing the actions required by the transaction. So you have a transaction like buying the biscuit, and you have a set of rules. It can enforce these rules on its own, and once enforced, or once it makes sure that these rules are there, it can start performing the actions required by the transaction. So thus we can say that that's why where the smart part comes in. You have something that is capable of enforcing rules on its own, and it can perform actions required by that particular transaction. So now coming to the smart contract. Okay, so you we talked about how we can replace a vendor with a vending machine, right? Now imagine a scenario where we can basically replace any and all of these third parties in a transaction using a code or a program. Okay, what you do is, suppose you are conducting a land transaction. What I do is, I program all these rules that is validated by the registrar or the government officials, and I create a program out of these rules. And I create a program in such a way that this program is able to validate these rules on its own. Okay, just like the vending machine, it is capable of enforcing these rules on its own. And once enforced, these this program can take actions associated with that rule or that transaction, which is governed by that rules. So such a program or such lines of code are what you call as smart contracts. Okay, these are, when you think about smart contracts, it's basically nothing but yeah. So sorry about that. Yeah, so when you're talking about smart contracts, it is nothing but a program. Okay, it's a program, normal lines of code. And in these lines of code, we define the set of rules that is required by a transaction. Okay, and this program is capable of enforcing these transactions on its the rules of this transactions on its own. And once enforced, the smart contract can take the necessary action associated with that transaction. So when you think of smart contracts, just picture a vending machine, the scenario of where vending machine replacing a vendor, and instead of hardware, you have program. Okay, you have a piece of code that is validating the rules and executing the necessary actions. Is that concept clear? Should I repeat myself, or should I explain more? Did you understand the concept of what a smart contract is? Yeah. Okay. So the thing is, the initial idea of a smart contract, okay, it is not, so most of us might confuse that, it was Ethereum that introduced smart contracts onto the world. The thing is, the concept of smart contracts is actually introduced, by this guy, and I mentioned his name somewhere. Yeah, Nick Szabo. This guy introduced the concept of smart contracts in the early 1990s. I think it was around 1994. He published a paper, and he did that for another crypto digital currency. Okay, I'm not clear about the, I'm not sure of the name, but he was working on another cryptocurrency, sorry, a digital currency of sorts, and that's when he introduced the concept of smart contracts. I think the year was 1994, and in 2013, Vitalik Buterin, the guy behind Ethereum, so he introduced the concept of smart contracts onto blockchains. Okay, and created what is called as programmable blockchain. So what do you think is the difference? What happens when you introduce such a program, or such a programming capability onto blockchains? So before Ethereum, one of the main major blockchain platforms, if you think about it, one of the major blockchain platforms was Bitcoin. So what do you think changed after the introduction of smart contracts onto Ethereum? What is your opinion? What was the major, change or upgradation that happened to this blockchain platform with the introduction of smart contracts? Yeah, any thoughts? You had a session on widely used for business applications. Yes, care to elaborate on that statement? Like, what does that mean? Like business applications in the sense?
See, initially, blockchain is about cryptocurrency, but
Yeah,
after the Bitcoin, in Ethereum or in other platforms like Hyperledger, they are widely used to, transaction can be recorded on the blockchain, so it becomes immutable to verify this transaction. And so
yeah,
it can be used for business application like transfer of the commodity or goods or product or ownership. So in that way blockchain can be used.
yeah. So That's, that is correct. That's exactly what happened. You see, with the introduction of such a concept like, a programmable, blockchains, or, where you introduce this, where you can execute these programs on top of blockchain network, what Ethereum basically did is that it widened the range of assets that can be dealt with using blockchains. See, until that time, you had Bitcoins, which basically revolved around that cryptocurrency, right? So, with the introduction of such a concept like smart contracts, now you can actually use blockchain to transact a whole array of assets. Basically, if you create a digital representation of any given physical asset, you can use these smart contracts to conduct transactions with it without the help of a middleman, right? So the major upgradation was that now, after Newton introduced smart contracts onto blockchain, it widened the scope of blockchains, right? Now, instead of just currencies like cryptocurrencies, you can use these smart contracts along with blockchains to conduct transactions of any given digital assets. Okay, so that was the major change that happened when the concept of smart contracts was introduced on top of blockchains. So what about bitcoins? We talked about bitcoins and this the era before and after smart contracts, right? So the concept is like, and like I said, when you are defining a smart contract, like I said, defining the rules of a contract, which essentially means that smart contract carries the logic of a transaction, right? So when you are when you're saying that you are you mentioned all the rules that should be done in this transaction, you are basically saying, or you are basically dictating the way in which that transaction is to be performed, right? So in essence, a smart contract carries the logic of the transaction. Okay, so my question is, what about Bitcoin? Did it have smart contracts, or how did it store the logic of its transaction? I told you that Ethereum was the first blockchain platform to introduce or to implement the concept of smart contracts. So before that, you had Bitcoin, and people were conducting this transactions using Bitcoin, right? So where do you think that logic lied? Where, the Bitcoin logic, where do you think it was stored? Any answers to that question? You can guess, right? Like I said, all of us are learning here, so there is no right or wrong. Where do you think that Bitcoin kept its transaction logic, or the rules to conduct this transaction? Any ideas? Yeah, so have you heard of something called as a Bitcoin protocol? You have, basically the people who created Bitcoin, they have hard coded all these rules onto the network. Okay, they didn't have a programmable or a dynamic concept like smart contracts. So what they did is they basically hard coded these rules required by this network onto the network itself. Instead of a separate smart contract or a program that can be run on top of Bitcoin network, the network itself, you had this, like the vending machine, it had this all these rules were hard coded into the network itself. Vitalik Buterin made it more dynamic by allowing users to write programs on top of blockchain. Instead of hard coding it, you can create your own custom smart contracts that carries the logic of your transaction onto and you can run these transactions on top of blockchains. So that is the initial idea behind, or that is the story of how smart contracts became a part of blockchain. So and how it widened the capabilities of this technology. Any doubts? Is the story clear, or are we on the same page, or should I explain? Uh, yeah. So that's how we came to this smart contract part. Now, what was the language that is used by Ethereum to write this smart contract? Which language did Ethereum use? Solidity. Yeah. Okay. Yeah. Just checking if you guys, yeah, paid attention to the sessions, before. That's it. So yeah. So you have smart contracts, which are programs that you can execute on top of blockchains. So did you understand how these two work? Like, you have, when you are considering a normal transaction, you have these third parties who helps you conduct this transaction, and you have the central authorities who store the records of this transaction and validate this transaction and keep its records, right? So here, instead of this third parties, you have the smart contracts, right? So the smart contracts contains the logic of your transactions. So, and helps you conduct the transaction without the help of a third party. So your smart contract basically helps remove the need of a third party. And once this transaction is conducted, once this smart contract helps you conduct the transaction, the record of that transaction goes into the blockchain, right? So you have a decentralized entity that keeps the record, or that validates all the transactions and keep the record of your transaction in a safe manner. And you have the smart contract that helps you conduct this transaction in without the help or assistance of a third party. Is that clear? Okay, so yeah, so this is how it looks like, when you compare a normal transaction to the one using smart contract. Suppose I want to buy a house. You have, this is the normal way, like you have to go through a whole bunch of, real estate agents, document writers, government officials, there are a lot of paperwork involved, and you have to, visit a lot of offices and everything. So what we do here, when you are thinking about smart contracts, what we do here is we take all the things that these people do. Like I said, these people they are here to validate the rules or the contracts of this transaction. They are here to make sure that we conduct this transaction according to the rules, right? So we take the rules of all these people, and we use a programming language, and we create a program out of it, which is called the smart contract. And thus, the thing is, you don't have to rely on all these people to conduct the transaction. Just like a vending machine. In a vending machine, you put the coin, and press what you want, and you will get what you want, right? So here in the smart contract, since you have since this program contains all the rules, all you have to provide is the data that is required to conduct these transactions, right? So suppose you are having a smart contract to conduct voting or something like that. So all you have to do is you have to provide the information which states your age and everything, and your nationality, or these things like that. And once the smart contract is able to verify or it is able to check whether everything is in accordance with the rules of the transaction, like the proper, if you are of the proper age or of the proper nationality or things like that. And once the smart contracts does all that, it will initiate the actions required by the transaction. Okay, in a normal scenario, you have to go through all these people, or all these third parties, and you have to provide information, separate information to each of these people, and that's how you normally conduct a transaction. Here you have a you have a program that takes the necessary data and conducts the transaction in a very streamlined manner. So when you picture a transaction with and without a smart contract, this is how it looks like. And the records, that in this case, these records are stored by different entities. Like the government will store a record in their personal database, or wherever. All these people have their own methods of keeping the records of this transaction. In the case of smart contracts, which is run on top of the blockchain, the records, once you conduct a transaction that is defined, or defined in the smart contract, the records are kept in a decentralized ledger, and nobody has control over it, which means that nobody can tamper with it, or nobody can deny service or things like that. So this is the general picture of how a transaction happens with and without a smart contract. Are we clear on this? Any doubts regarding any of those concepts? I mean, with smart contracts? Yeah, if yeah, so let me just so yeah, so as we said, in the blockchain network, these smart contracts are, I know I'm not diving into that depth, because you had this session on Ethereum and everything. So I'm assuming that you have a fair idea of what a node is. So what is a node, basically? What do you mean by a node in a blockchain network? When
It is
you
nothing. It is nothing but one of the computer system, no?
Yeah,
Where we can write our coder that take part in means it is part of distributed system. Blockchain works on distributed network.
yeah.
So one node means one computer.
Yeah, so it is the computational device that is part of this network, right? So the thing is, when you're talking about, blockchains, you a node is basically a computational that is part of a computational device that is part of the network, which hosts the complete record of that ledger. Okay, there is a bit more to it, when you're talking about a node in a Bitcoin or a blockchain network. The thing is, it is a computational device that is part of the network, and it hosts the entire ledger, okay, or the entire record of transaction in that device. So the smart contracts, since they are the participants in the network, the smart contract is also hosted by the nodes in the network. Okay, you don't have separate services like, you have application servers and everything for normal web applications, things like that, right? So here, the participants, there is no separate server or anything. This contract is actually hosted by the nodes itself. And like I have said, the transaction or the smart contract basically carries the rules uh, that governs the transaction, right? Which means that they dictate the logic of that transaction. So when you are defining a smart contract, what you're doing is you are defining the logic of that transaction. Okay, and apart from defining the logic, you also get to say, or you also get to define the asset that you are transferring, right? So if you are dealing with your account, I mean money, or anything, car, property, or anything, the smart contract also helps you define the assets that you are dealing with. Okay, so this is the general idea regarding a smart contract, and I hope it was fairly simple. I mean, yeah, we'll get to Node.js. I mean, the Node.js part. Yeah, it was actually pretty good for blockchain. I mean, we use it for blockchains. I mean, in the afternoon session, the next session, I think I have 2 sessions after this one. So in the next session, I will show you how to write the smart contracts using Node.js. So yeah, yeah. So apart from defining the logic, you can also help, you can also use the smart contract to define the assets that you are using in this transaction. So like the thing is, when you talk about blockchains, you have decentralization, no third party and everything, and the smart contract basically helps you with removing the reliance on third party by helping you conduct the transaction. And since it is a piece of code, right, since this is a piece of code, there is no tampering with it. And the thing is, one thing that you have to understand is that when you're thinking about smart contract, just because you can write a smart contract doesn't mean that it will become the part of a network. The smart contract has to be agreed upon by the participants in order for it to be a part of the network. You can't just type in a code and expect it to be a part of the network. It has to be properly endorsed or consented by the participants of the network in order to be for it to be a part of the network. So this is how these are the basic concepts of a smart contracts. uh, yeah, so next comes the chain code. So what is your idea about Hyperledger Fabric? you know what do you when I know that you guys had a session regarding Hyperledger projects, in the morning. So what is Hyperledger Fabric, or what is your idea regarding Hyperledger Fabric? What are its specialities? Like, when you compare Ethereum and Hyperledger Fabric. Okay, and why do we use Hyperledger Fabric? What is its major use? Any idea? Industrial applications. Yeah. So the thing is, Hyperledger Fabric is a project under, it's called Fabric. It's a project under the Hyperledger, a project that is run by Linux Foundation. It's a project that is incubated under, it's not incubated, it's actually production ready. The thing is, it is a project under the Hyperledger community, and it is basically used, like he has mentioned here, it is actually used for industrial or enterprise use cases. And, this Hyperledger Fabric, it is, you know, used, yeah, create multiple channels. Yeah, that is part of, that is actually a functionality of it, like the process of creating channels. The thing is, you can use this Fabric network in order to map a consortium model. Suppose you have multiple organizations that is part of a network, like, a supply chain application or things like that, where you have multiple organizations, who has to coordinate among themselves and, share information and everything. So in such a scenario where you have this consortium of organizations, that is where you can use Hyperledger Fabric network. So chain code is basically the place where we define the business logic, yeah, used to authenticate member identities. Yeah, the thing is, like I said, these are the functionalities of Hyperledger Fabric network. It is a open source private permission network that was created or that was first contributed by IBM, and it is used for enterprise use cases. And it is especially effective when it comes to mapping consortium models, consortium business models onto blockchain. And this chain code is where you store the business logic. Okay, you have, when you're conducting business, like, you have this logics of all your transactions, right? So a chain code is where you define the business logic in this Hyperledger Fabric network. Now, there is a subtle difference between a smart contract and a chain code. Okay, as I mentioned here, a chain code is essentially a set of programs that runs on top of Hyperledger Fabric network, which means that a chain code is actually a group of smart contracts. Okay, you take a set of related smart contracts and you create a group of it, or you group them together, and that's when you create a chain code. For example, suppose I'm creating a smart contract for the a bus or to conduct a transaction for a bus, and suppose I create another one for bike and another smart contract for car. So a chain code is basically a group of such related smart contracts. So I have a smart contract for bus, bike, car, and etc. So what I do is I'll create a chain code called vehicle, which hosts or which clubs together all these related smart contracts into a single group. So when you think of chain code, the only difference is that instead of a single smart contract, a chain code is essentially a set of related smart contracts. Okay. Now, one of the major, you know, plus points of Hyperledger Fabric is the fact that it is I think the first platform, blockchain platform, that allowed the use of general purpose languages, like normal languages, programming languages, for writing smart contracts. You already said that in Ethereum, we use a language called Solidity, right? Now, Solidity is a language that was developed for that particular purpose. It was not a general purpose language, or it was created for the purpose of Ethereum, or for writing the smart contracts for Ethereum, right? But with Hyperledger Fabric, the thing is that they wanted it to be used for enterprise use cases, right? So an introduction of a new language like Solidity to generate smart contracts or chain codes will result in a higher learning curve, and it will take time for people to adjust to this Fabric networks, right? So what they did is they allowed the use of general purpose languages like Go, Golang, Node.js, and Java. So people, who already know these languages, they can simply, shift to this Fabric, and they can start developing chain codes in Fabric network using those languages. So that was one of the major plus points of Hyperledger Fabric. You can use these things. I mean, there are other languages. I think they are developing one for .NET, and everything. But these are the major three languages which you can use to develop chain codes in Hyperledger Fabric. And so you have various SDKs for each of these languages, and you can use it to generate smart contracts and chain codes in Hyperledger Fabric. So yeah, now uh, do you remember in the previous session? I hope that you guys had an introduction to what an endorsement policy is, right? Do you remember what a endorsement policy is? You had a brief introduction regarding the concepts and the elements of the Hyperledger Fabric network, right? So I'll just give a very brief overview. So we talked about how Hyperledger Fabric is a private permission network, right? So it means that people need certain permissions, or people need certain authentications in order for them to be a part of the network. And once they are part of the network, in order for a transaction to be conducted in this Fabric network, it needs to be endorsed. Okay, so I will explain the process. Like suppose you go to a bank and you want to avail a loan. Okay, so it's not like you just write in a piece of paper and you just give to someone in the bank and you get a loan, right? You have to create a request for that loan, and you have to produce that request, or you have to give that request to the manager and that or the accountant, or the people who are responsible for availing a loan. So you will get a loan once these people, or this hierarchy of people, endorses your loan, or they make sure that everything is okay and everything, and only then will you get a loan from a bank, right? So the thing is, here you have a set of people who endorses your loan, and that's the only way you can avail a loan in a bank. So similarly, when you are talking about a Fabric network and a transaction, you have a set of nodes or peers who are responsible for endorsing certain transactions that is part, or certain smart contracts that is part of the chain code. Okay, so these are called the endorsing peers. Okay, a peer is another term for node. So you have a certain, just like you have the man in a bank, you have a certain set of people who are there to endorse, the loans or transactions like that. Here you have a certain subset of peers who endorses the transaction. Okay, so in this Fabric network, these endorsing peers are the ones who host a transaction, or hosts the logic of a transaction or the chain code. Okay, you have a certain set of peers who are there to endorse a transaction, and the only way to endorse a transaction is to know what the transaction is, right? You can't endorse something unless and until you know what is happening, right? So in the example of the bank, the reason why you don't go to a clerk and ask for a loan is because that the procedure is governed by, or the manager is the one who understands the procedure. So he or she is the one who has the authority to endorse this transaction. That's why you go to the manager and not a clerk, or an IT technician or something. So similarly, when you are thinking about this Fabric network, you have this uh, nodes who endorse, or the peers who endorses the transactions, that is defined in the chain code. So it is those peers, or these endorsing peers, that hosts the chain code, or host the group of smart contracts. No other peers are required to host a chain code in the Fabric network. Is it confusing? Did you understand the general gist, or the general idea behind this concept? You have a set of peers responsible for endorsing a transaction, and only those peers should host a chain code, because they are the ones who should know the chain code, or the logic of the transaction that they are endorsing, right? So they are the ones who hosts the chain code in their system. no other peer. There are other kinds of peers in Fabric network. They are the ones, those who don't endorse these transactions. So if a peer doesn't endorse any transaction, they need not keep a copy of the chain code. Now we will see how all this works, in the coming sessions. But is this concept clear? The concept of an endorsing peer, and how and why it hosts a chain code. Do you have any doubts regarding that part? You can just reply in the chat. Is there any doubts regarding that? Yeah. So, yeah, the thing is, each transaction, it will have, since they are the ones who host this chain codes, the ones who endorses these transactions, they are actually responsible for making sure that the transaction holds these endorsement policies. Now, if someone, in the last session we talked about endorsement policies. I know Praveen, I think he had the session regarding Fabric, and I hope that he mentioned endorsement policies. If not, the concept is that you can define who should you can define the number of nodes, or the nodes which should define which should endorse a transaction. An endorsement policy states the nodes that should endorse a transaction. Yeah, that's membership. Like, this is an example. Just that's part of the MSP and everything. So just don't go that's a bit technical. Like, it's part of the identity and all. I just want you to focus on this peer right here, and you can see that endorsement policy and consensus are different. Endorsement policy states the peers that should endorse a transaction, right? So, like I said, in order for you to avail a loan, you should get the approval of the bank manager or the accountant. But in order to cash a check, you just need to go to the cashier or the teller, right? So these are, when you look at the bank, these are separate transactions: availing a loan and cashing a check. You have different people responsible for approving these transactions, right? So here in Fabric network, we define these approvals, or we define these the nodes that are responsible for this endorsement in the endorsement policy. Consensus is when the entire nodes decide which or what data to write into the ledger. So endorsement policy basically tells you who needs to endorse a transaction, and consensus is a general agreement that the nodes have about the data that should be written into the blockchain or the block. So it is different. Yeah, and I don't want you to focus on this membership part right now. It requires a whole session of its own. That's why I'm not diving into it. Just focus on the peer. That's it. Here you have this. This is an endorsing peer, and you can see that it hosts a chain code. So that's it. Don't get carried away by the figure. I just want you to get a general idea of what this is. So yeah. So any other doubts regarding this network? So just know that there is a you can define the peers who are responsible for endorsing a transaction in a Fabric network. Okay, not all you can say that a certain subset or of peers should endorse a transaction in order for it to be added to the ledger. Okay, so that's where the endorsement policy comes in, and it is verified by the peers. Once this transaction is part of a block and that block is distributed to the peers, they verify this transaction is every peer will basically check the endorsement policy and make sure that it is properly endorsed. That's it. So I hope that is clear. Yeah, so this is the general idea. So you have the chain code, which is basically a group of smart contracts that contains the logic of your transactions. And you have these endorser peers who hosts these chain codes in the network, in the Fabric network. So yeah, moving on. Yeah, there are certain stages. Who will be, sorry, that question is not clear. Can you be a bit more specific? Yeah, there is a question, who will be peers in all? I didn't understand the question. Can you be a bit more specific?
Who will endorse this actually? Peers means, and
Yeah. So the thing is, peers are, another name for nodes itself. They are this, servers or computational machines that are part of the network. So certain peers, like I said, certain nodes or peers in this network will have a special functionality to endorse a transaction. Okay. It is a certain functionality that you provide to a particular peer or a node, and you define that policy or that rule in this endorsement policy. So you have this endorsement policy which says the which dictates who all should endorse a particular transaction. So yeah, so it is these peers, who are stated in this endorsement policy, they are responsible for endorsing a particular transaction. Each chain code will have an endorsement policy, which means that each chain code will, this endorsement policy will say that who all should endorse a particular transaction, under this chain code, that is defined in this chain code.
Okay, is
So
there any criteria for that, or anyone can be peers, or somebody will be setting that?
yeah, you can, if you're talking about peers, like, since it's a permission network, if you have the proper authentication and the authorization, you can host a peer in the fabric network. In order for it to be considered endorsing peers, it is actually the decision of the organizations. Like, they get to decide, who gets to be an endorsing peer for a particular transaction. Yeah, so this is like when you are talking about the architecture of this fabric network, you can I can actually take a whole session or a whole couple of session on its own. Just know that you have nodes. Don't get confused by the name peer. It's another name for node. In Ethereum you call it as node, and in fabric you call it as peer. That's it. And you have lots of peers in this. You can, organizations, they can add peers to the network. If there are three organizations, they can add n number of peers to the network according to their wish. And the thing is, a certain subset of peers, they will have an additional functionality to endorse a transaction. Okay, that is defined in this chain code, and that subset is defined, or the group of people who should endorse this transaction, that policy, that is defined inside an endorsement policy. And these people, these peers who are responsible for endorsing this transaction, they are called these endorsing peers. It's an additional functionality of uh, you have normal peers and you have peers who could endorse. That's just an additional functionality that is provided in the fabric network. So yeah, uh, uh, yeah, about the chain code. So the thing is, in the fabric network, it's not like, you just write a piece of program and you just deploy it onto the network. There are certain stages, you know through which we should add this chain code onto the network. It's not as simple as running a program in our system or things like that. So it goes through three different stages. Okay, a chain code, in order for it to be a part of the network and in order for us to conduct transactions using it, it goes through three different stages. And the first one is called packaging. Okay, so once you write a chain code, you know you have, once you finish your chain code, once you're done with the code, the first thing is you should package it. Like, along with the chain code, you should have this the policies regarding, where to instantiate or which peer to instantiate on, like the you know you have your chain code along with certain metadata regarding the chain codes, and you take all these details and you package it into what is called as a CDS, or a chain code deployment spec. Okay, it's like, how you compress all your files into a zip or things like that. So similarly, you take the chain code and you take certain metadata regarding that chain code, and you create a package, sort of, you package it into what is called as a chain code deployment spec. And you distribute this CDS, or this chain code deployment spec, which contains the chain code along with certain metadatas, and you distribute it to the necessary peers, like the endorsing peers. And once you distribute the CDS package to all the required peers, like the endorsing peers, they install the chain code. Okay, what they do is initially they install this chain code. Okay, they install this chain code onto their system, like all the peers, peers that endorses a particular chain code. What they do is they will take this package, the CDS package, and they will install this chain code. Okay, and they can check all the details of this chain code from the metadata that is packaged in the CDS, and they install this chain code, and thus they will have an instance of this chain code in their system. Like the peer will have a chain code in the system. But so after packaging, the next stage is the installation of the chain code in the required peers or the endorsing peers. So the thing is, even after you install it, you can't interact with the chain code unless it is instantiated. Now, what is the idea of a channel? Like, somebody mentioned a channel, the property of a channel, right, in Fabric network. So what is a channel? What do you understand by the term channel? What is the idea behind a channel in a Fabric network? Yeah, it is very similar to VPN. You have the internet and you have the VPN, right? You know about VPNs, right? Virtual private networks. You have the internet where everything can everybody can connect with each other, and you have a VPN, which is like a closed room or a sub network, or inside which only a subset of these people can interact. So a channel is very similar to a VPN. So the thing is, a chain code is usually associated with a particular channel in this Fabric network, right? A channel is the one, so you have this group of people who are part of this channel, and a chain code is associated with that particular channel. So once you install this chain code onto the peers or the endorsing peers in a channel, then you have to instantiate that chain code, or you have to it's instantiated. Think of it as a message that states that this chain code is part of a channel. You have to state that you have such a chain code that is part of your channel. So that is what the process of instantiation does. It basically tells that this particular chain code is now part of this channel. So once everybody installs this chain code, that is every endorsing peers install the chain code in their system, then what happens is that the chain code gets instantiated onto a channel, by which the channel becomes aware of this chain code, and all the people and the chain code get initialized. Like for example, it's like think of this, it is very similar, when you are trying to compare it with a real life scenario. Think of this exam hall. Like the installation will be similar to you handing out this exam sheets to the students. Now you have every students who are part of the class, they have this exam sheet with them. Instantiation is when you tell them to start writing or filling in the details of this in that exam paper, so that the exam is officially which states that this exam has officially begun. So similar to that, you have when you are thinking about chain code, you install this chain code onto all the endorsing peers, and then you instantiate that chain code onto the channel. And when this instantiation happens, that's when the peers, they compile and they build this chain code, and they run this chain code during the instantiation. So when you instantiate a chain code on the channel, that's when they run, they build, they compile, and they run the instance of the chain code. All the endorsing peers in that channel, during instantiation, they run the instance of the chain code. And once they run the instance of the chain code, that's when we get to interact with it. So once you write a chain code, you package it, then you distribute it to the required endorsing peers who install that chain code onto their system. And once everybody installs this chain code, what they do is the chain code gets instantiated on this channel. And once during this instantiation, all the peers, all these endorsing peers, they start to initialize this chain code, and they will run uh, an instance of this chain code in their system, and then we can communicate with that instance of this chain code. Now, this might be confusing But the thing is, in the afternoon session, I'll be showing, how to do all of this in the lab sessions. I think I have another session at 2. So we'll be going through each and every one of these steps. So just know that you have 3 steps, that is the packaging, the installation, and the instantiation. Packaging is basically you bundle up all the details of the chain code along with it, along with the chain code. Expiry, no, you can update it. There is no expiry. It doesn't expire. You can delete or remove a chain code, or you can update it. I'm not aware of any expiry that is part of this chain code. Yeah, you install this chain code in the peers or the endorsing peers who host this chain code, and then you instantiate it on the channel. Like I said, a chain code is associated with a particular channel. So once you instantiate a chain code onto the channel, that is when these peers, they start running an instance of this chain code in their system, and then you can interact with it. So this is the don't worry about it. You will get we will go through each of these steps. I'll show you how to do this in the lab session, in the coming session. This is basically the theory part. Just know that you have to go through all these processes in order to make a chain code part of the network. Okay, so yeah, so the next is, yeah, so yeah, the thing is, when you look at the structure of a chain code, every chain code implements 2 separate functions called the init function and the invoke function. Okay, the init function is basically a constructor. Its functionality is very similar to that of a constructor. How we have this class, and inside the class, in order to initialize the required variables, we use a constructor, right? So similarly, you have this function called init, which is invoked, as it says here, it is called when the chain code is initially deployed onto a network, or when it is upgraded to a newer version. So you have this sort of a constructor function that should be implemented in a chain code, and its purpose, as the name suggests, is to initialize the variables or the necessary data for the chain code. Then you have something called as the invoke function. Okay, now the invoke function is called when you try to invoke a smart contract or a transaction logic inside this chain code. We told how we define these smart contracts or this transaction logics inside a chain code, right? So whenever you want to invoke a particular transaction, that's when this invoke function is called. Now, this is a bit technical, so the thing is, you have, as a part of this Fabric SDK, you have something called as the chain code interface. So both these functions, you know what a class and interface is, right? Yeah, yeah. You have this thing called this chain code interface, and these functions are actually a part of this chain code interface, which is part of this Fabric, code. So every chain code must implement this chain code interface, and thereby they should override, and they should not override, sorry, they should implement these functions in their chain code, the init and invoke. And all this chain code interface, which hosts this init and invoke function, they are part of something called as a Fabric shim package, which helps the chain code communicate with the peers. Okay, a shim. Do you know what is the meaning of a shim? Like literally what a shim means? Does anybody know what a shim is? Does anybody have any basic idea regarding carpentry or things like that? Now there we use, it is very common, this word shim is very common in such fields. Do you know what a shim is? So in this, when you a shim is basically a small piece of wood or any element that is placed between 2 things so that it fits perfectly. Okay, so you have this thing called Fabric shim, which is a package which helps the peer to communicate with the chain code, or the chain code which deals with the chain code peer communication. Okay, you know that the endorsing peer hosts this chain code, right? So there should be a mechanism that using which they should be able to interact with each other. So the fabric shim basically helps that, and inside this fabric shim package you have something called as a chain code interface, which hosts two important functions called the init and the invoke function. Now, yeah, so this is the basic thing that you have to understand, before you start. There is a bit more to it. You actually, when you are writing the chain code, I will explain certain things. It's not as complicated as it seems, and I'll tell you why when you're in the lab session. So just know that there are two important functions called init and invoke. And the init function is basically a constructor that you use to initialize a chain code, the necessary variables inside a chain code. And invoke is a function that you invoke when you are conducting a transaction. So this is the overall architecture, like, these two functions basically comprise of the architecture of or the structure of this chain code basically comprises of these two functions. So yeah, now the thing is, each chain code, you need data, right? In the when you are talking about a program that runs on top of blockchain, you need to handle data, right? So a chain code manages what is called a state. Now, have you heard of this term state before? When you're in the previous, I think in the Ethereum session, you might have dealt with states, right? So what is a state? What do you mean by a state? Any ideas on what a state is? When you're dealing with this smart contracts in the Ethereum, you constantly deal with something called as a state of the blockchain network. So what is it? Values of all, okay, state variables, okay. Any other definitions or regarding what a state is? You see, the thing is, in the blockchain network, you know that this ledger contains the details of all the transactions, right? If you're talking about the Ethereum, it will tell you all the transaction or details of all the transaction, and it will tell you how many ethers are left with a person or things like that, right? So what if I want to know the current balance or my current, suppose I have an account in Ethereum, or I have a wallet in Ethereum. What if I want to know the current balance of my account? What process should I use? How can I get the current balance of my Ethereum wallet? Or I created an application using Ethereum, and I want to know the current balance of ethers in my account. So how would I know it? What is the possible, what have any possible ideas regarding how I could find the current balance of ethers left in my account? So one of the possible ways, possible ways is to go through each and every single transaction and calculate the balance, right? But the thing is that takes too much of a time. It is like relying on your bank passbook in order to calculate your bank balance. Okay, it will be time consuming and it will be very counterproductive, right? So what these platforms does is they will create something called as the state of the network, which tells you, yeah, somebody has already mentioned it, which tells you the current state of that network or that asset. Okay, so instead of going through all the transaction one by one and calculating or reaching the final stage of the asset, I can refer to the state of that network or state of that particular blockchain asset or network, and that state will give me the current picture, or it will show me what is happening at the current state. So the thing is, instead of going through all the transaction, now I have this field or I have this thing called state, and I can use the state to understand what is happening right now with my asset. Did you understand the concept of a state? So without a state, it is like calculating your bank balance using just your passbook. So, without a state, in order to understand the current state of your asset, without the world state, in order to understand the current state of your asset, you have to go through every single one of the transaction and arrive at the conclusion on your own. With the state, you can just refer to the state to know the current picture of your asset. Okay, so is that concept clear regarding the state? Should I explain it, or is it confusing? Yeah. So, okay. So what in this fabric network, the thing is, each chain code maintains a separate state. Okay, you have the ledger which records all the transaction, and each chain code, okay, each chain code manages a separate state of this ledger. And when a chain code, when you invoke a transaction in this chain code, these chain code refers to their own private world states, and they take the details from that state. Okay, it's not like a global world state, and every chain code accesses a global world state. Each chain code basically has their own separate world state, or they maintain a separate world state. Now, the details, you have the ledger which records the transaction, right? These world states are usually kept in fabric. These world states are kept in databases. You use databases like couchdb or leveldb and things like that, and there you store these world state. Okay, so each of these chain codes, they manage their own separate world states, which contains the current state of an asset that they're dealing with, or the current state of affairs of the network. And they use their own private world state to conduct to access the information regarding an asset or things like that. So the thing is, within the chain code, all the smart contracts that are part of the chain code can access the same world state. They have a private, each chain code has a separate world state, and all the smart contract that is part of the chain code can basically access the same world state. Now, the thing is, like I said, a world state is associated with a particular chain code, right? So in a network, suppose I have a couple of chain codes that are part of the network. You need special permissions to access the world state of a separate chain code. Okay, even if you can access the world state, you cannot write something onto a world state of a different chain code. You can just read the information from this world states. Okay, so given the proper permissions, you can actually access the world state of a separate chain code, but you cannot write to that world state. You can just read from that world state. And in fabric, this is pertaining to fabric, this world state, usually in ethereum you just call it the state of the chain. In fabric you call it as the world state. So the thing is, in the world state, you store the data as key value pairs. Like if I will show you how this works, but just know that it is stored in the form of a JSON object or a dictionary in Python. You know how a key value pair works, right? You will have an identifier and you will have the value associated with that identifier. So that is how you store the data in a world state. Okay, so you have a chain code which contains the transaction logics of your transactions, and it is hosted by these endorsing peers, and you need to package a chain code, you need to install it, and you have to instantiate it in order to interact with it. And within this chain code, you have the init and invoke functions that you have to implement. And this chain codes, they deal with their own world states that carries the current state of affairs of this network. And each chain code has their own private world states that they use to access the information pertaining to pertaining to an asset or things like that. So just to give you a picture, this is a general idea of how of how things are. You can see that just don't worry about the overall technicalities. Just know that suppose if this is a peer, you can see that it can host multiple chain codes. Suppose it is endorsing multiple transactions from different chain codes. So it is endorsing, since it's endorsing multiple chain codes, it will have instances of multiple chain code. You can see that there is a paper chain code and there is a bond chain code, and you can see that each of these chain code, they keep a separate world state inside a database. Okay, in Fabric they use a database called CouchDB to keep the world state. You have the ledger here, you have the blockchain that records all the transactions. You can see that there is an add, update, and all those transactions that is recorded in the blockchain. And you have the database that keeps the world state or the current state of the asset. So that the reason why we use a database for that is because this chain code, when you are conducting a transaction, a chain code might access these details thousands of times. So instead of just accessing the ledger every time, you keep it in a database so that it is much more easier to query. Okay, so yeah, so like I said, every chain code will keep a separate database, and inside sorry, not a separate database, a separate world state which is hosted in a database. So this is how the overall picture looks like. A peer hosting a chain code which has these are the functions, like or the smart contracts that defines the rules for these functions, and each of these chain codes, they will host their own private world state which keeps the details regarding the current state of affairs of an asset that they are dealing with. And these world states, they are kept in a database, and the transaction details are kept in a separate blockchain. They have these blockchains where they keep these details regarding a transaction, and the end result of this transaction or the current state of things are stored in the world state which is hosted in a database. Is this clear? This is how no, it's not central. It's not a central. Each node will have their own separate databases. Now, the database is just there to protect, just there to keep the world state. There is no like I said, it helps you query faster. It's not like a central repository where you keep all the world states. This is a node and it hosts its own database. It's not a heavy database like an SQL or something. It's usually, they use databases like CouchDB or LevelDB to handle the world state. So this is the picture. So do you have any doubts regarding what a chain code is? I mean, the way I see it is, unless and until you have a proper idea of what chain code is and what it does, there is no point in conducting a demo session, right? So if you have any doubts regarding chain codes, please let me know and I'll clarify. In the next session, we'll be exclusively dealing with the creation of a chain code. We will put all this into practice. This is basically the theory session, and we'll put all this into practice in the next session, and I'll show you how to write your own chain codes. So yeah, any doubts regarding what a chain code is? Do you understand the concepts and the processes of this chain code? And did you get a general idea about what a smart contract is and how it helps remove the third parties from a transaction? So if you have any doubts, I think, for this session, I think, yeah. So
there will be multiple endorsement fees, right?
Yeah, a transaction can have multiple endorsements. Yeah.
So when we submit a transaction, it can happen on all that peers.
Yeah. So this transaction proposal, I think, yeah, once you propose this transaction, it goes to these endorsing peers. If there are multiple peers endorsing this transaction, the proposal of your transaction actually goes to these peers.
All of these peers. All of these peers.
All of these peers who are supposed to endorse it.
Okay.
Yeah.
Okay.
Yeah, which node? Yeah, like I said, the nodes which is responsible, or the peers which are responsible
because it's a distributed system, right? So
yeah.
Okay.
Yeah. So no, I was just answering this question that came up in the chat. So which node will be running the chain code? Like I said, the node which is responsible for endorsing the transactions in the chain code, they will be responsible for running it. Yeah. So any other questions regarding the is it a central database accessible by other? No, like each peer maintains a separate database. Like, they have separate databases that they maintain. It's not like a central repository where they store all the world states and everybody can access it. No, it's like separate things. The ledger will be shared, like a copy of the ledger will be shared by everyone.
Sir,
So-
what are the different types of peers peers in the Fabric network?
Yeah, you have this endorsing peers who has this functionality, like I mentioned. Then you have something called as a committer peer. Okay, so the committer peer is any peer that can add, which hosts a ledger and that can add data or add blocks to that ledger. So like in this, I'll give you an example. Yeah, so here you can see that this every peer, a node in this Fabric network, like I said, it hosts the ledger, right? So every peer by default is called a committer peer, since since it hosts a ledger. Whenever this peer receives a new block, every peer is able to add that new block to its ledger, right? Once they have this consensus, once they do this consensus and everything, and once this network generates a new block, every peer is able to add that new block to its ledger, right? So every peer by default is what you call a committer peer, or a peer which is capable of committing the blocks to its ledger. A certain subset of this committing peers have a special functionality wherein which they can endorse a transaction, and they are the ones we call the endorsing peers. And then you have the ordering peers who are responsible for ordering the transaction and creating a block out of this transactions. And then you have certain other labels that you give for peers for specific functionalities, but I don't think we should dive into that details. You have things like anchor peers and things like that. So it is like it has subtle differences when it comes to the functionalities, but generally you have the ordering peers, you have the committer peers, which are the default stage of a peer. Like every peer can commit the blocks to its ledger, and then you have the endorser peers who has this additional functionality to endorse a transaction. So yeah, is that clear?
Yes, sir. Yes, sir.
Yeah. Priority in the transaction, yeah, so means if a committer peer, if you configure a committer peer to endorse a transaction, then it becomes, if you add a committer peer to your endorsement policy and says that it should endorse a transaction, then it becomes an endorsing peer. By default, every peer that is part of this Fabric network is actually a committer peer, since it can add the details of this blocks into its ledger. Since, like I said, peer is another term for node, and a node hosts the entire ledger, right? So every node in this Fabric network, they are capable of adding blocks or committing the blocks that are coming their way to their ledger. So technically, when you are adding a peer, it automatically becomes a committer peer. Then you can add this additional functionality called the endorsing functionality, and then if you if you allow a peer to endorse a transaction, then it becomes the endorsing peer. That's the only difference. Those are the general categorization. Like the ordering peer, they are responsible for ordering the transaction and creating a block. Then you have the committer peer, which is the default state of a node or a peer in the network, and then you have the endorsers who are capable of endorsing the transaction. You have other subdivisions, like that is based on the architecture and everything. I don't think I should be explaining all that, because then it will take away from the focus of this session. So is there any doubts regarding what a chain code is and what the functionalities of a chain code, or anything? Any doubts regarding the theory part of what a chain code is? So if there are no other doubts, I think we can break for lunch, and after the lunch, I'll give you the demo, and I'll show you how to run.
Okay, sir. We will continue at 2 o'clock. Hello, sir. Hello. Sir, I will
Yeah.
continue at 2 o'clock.
Yeah. Okay. So
So we will break here and we will continue at 2 o'clock.
I'll just wait. Yeah. So I think we can break for lunch, and we'll meet back at 2 o'clock. I think. Yeah.
Okay.
So thank you.
Thank you.
Thank you for
Thank
your
you, sir.
time.
Okay.
Yeah.